American.
Yeah, let's put it this way. If you said to someone back home, let's go out for breakfast,
It could mean anything.
it could mean anything.
Yeah,
But
anything.
like,
Couldn't be
you
anything.
can't have any foods for breakfast. There are some specific foods you could have for breakfast. Like maybe it's
specific ones for breakfast, but
Like, 'cause,
there's a range.
yeah,
There's
there's
a broad range.
Yeah,
Yeah.
Yeah.
because
So because I remember when I was learning English, they were saying, no, there's some things you shouldn't talk about in class. Like, if you talk about bacon or pork, it might offend people. Like in English class, I'm like, yeah, but students should really learn that the word breakfast in Ireland means, one thing that maybe they don't want to be eaten. I just think it's funny.
I tried it once by mistake too.
By mistake, yeah.
No, I was out with Rahman. Do you remember Rahman,
Yes.
the Malaysian guy?
Yes.
And he was fully convinced that this pizza place is like halal. So he's like,
This is definitely halal.
Yeah, we went and
Sure.
it was 4 a.m. and like we were like, okay. And then it was like, let's order a margarita. And then he was like, no, let's order pepperoni. This is halal. And then I asked the guy that's working there. I go like, is it beef pepperoni? He's like, I don't think his English was that good.
Oh dear.
He was like, yeah.
Yeah, beef pepperoni, yeah, whatever you say, sir.
And then we got this big pizza and I'm eating and it tastes beautiful.
Yeah. No, that's the other thing, pepperoni, because I suppose back home pepperoni is made out of beef for you.
Yeah. There are some.
So when you say pepperoni, you automatically think it's beef.
No. We know that it's not. But then if someone tells you that it is, because like there are some shops that sell beef pepperoni, like the pizza shop.
Okay. They do beef pepperoni.
They have,
Yeah.
They have and bacon.
Yeah.
Halal bacon.
Halal bacon. Yeah.
It's like turkey.
Yeah. I sometimes go into the halal shop because I like trying different things.
Yeah, they have nice things.
They have nice things in that halal supermarket shop at the bus stop.
Yeah.
Myself and the biology teacher, we get things there sometimes.
The mangoes are really good.
Yes, actually, that's what one of the teachers was getting yesterday.
I had,
the
but
fruit.
it was super expensive. I got one. It was for one mango was for like €3.
That's super expensive, I suppose, for you, is it?
Like, isn't it for you too?
Depends how big it is. How big is the mango?
Like I got another one from Camden Street, like one of the people that were selling.
Yeah.
And I got like one that was twice the size of that mango. This one was like 300 grams, maybe.
How much?
Basically, it was €8 for a kilogram of mango. So.
How many mangoes did that make?
What?
Did you count them?
I didn't buy a kilogram. I didn't
By
have
weight,
kilograms.
yeah.
I bought one, and plus if I bought kilograms, it's just one.
Yeah.
But the one
Mango is something we would have to import here. We don't grow it naturally. Why it's expensive, I think.
maybe.
If you want cheaper fruits, it's going to have to be things like berries, strawberries, raspberries.
No, but
You
the
like
one
these, don't you, or not?
Yeah, the one I got from Camden was like big.
But I suppose strawberries should be expensive back home for you, is it? Or
The fruits are not that expensive.
no?
Like, because until now they are not that.
Oh, okay. Now what are we going to do? Because I said we're going to do the maths coursework, but there's only two of us. I mean, I can still do it, but
Can we revise like trapezium?
but half the class, you see, there's only two of you, and I might as well do something that you two particularly want. Have you started the maths coursework? And which task are you on?
Second task.
And how
I did, like, I went through it and I have a couple of questions.
Oh, so you have particular questions.
Yes.
Good, okay, so will we answer those first? And then you haven't started.
Yeah.
So if you listen to his questions, you might learn something. Oh, it's not on. Oh, finally, Fawn, we had 1 minute left. No, you have 1 minute left.
Wong and Omar are not going to be.
They're not coming.
They're sleeping?
Oh, by the way, where are we having the second lesson? When? And what?
2 to 4.
Yeah, D2 and 3 or something, isn't
2
it?
to 4.
That's physics and math.
Whatever, yeah, what else? Just call it Stephen Cross. That's all it is. Do you have your coursework for
Do
all?
you?
What?
Do you know why?
Why what?
You have,
You want to see
don't tell
it.
me you forgot your laptop.
No. Connell?
Yeah.
You want to see it today?
It was like
Okay, let me see.
Hmm.
Maybe I can do something about it.
Fawn, do you mind turning the projector on? If you can reach, use all your strength. Do it! Thank you. Easy peasy indeed. We are waiting for Yusuf. He has questions. Do you have questions about the coursework?
Oh, we do couple of those on the
Coursework.
We'll do coursework now. And yeah, we could do some maths questions later after lunch. You can be working on your coursework, Yahya. You two have the same question.
Yeah, we were working together. Yes.
Oh, good. And you can understand Fuan?
no.
I hope she understands me.
You can understand him?
Yeah.
Oh, good.
I can understand her. So,
I thought I can understand what question you're talking about.
But now you can?
Neither.
You have questions too? Who will have the questions first? What's happening on your computers? Are you booting up or something?
I need to connect to the internet. Do you know the
Yeah, but what's the network?
password for the GNC guest Wi-Fi?
Oh, yes. Actually, you know what?
You can
I have
get
it.
from here.
I have it saved. I can put it on the screen. It's Griffith College, but it's like the I is replaced by
Oh,
the
yeah.
one.
It's the capital G
Yeah,
and ones instead of I's and
trees instead of E's, and a capital C as well. But
You mean?
no. I'll put it up on the screen so you can all type it in if you need to. Well, if you want, I can make a hotspot on my phone.
I can do that too.
I can't actually.
Yeah.
Right, where is it now? Wi-Fi, is it this one? Yeah. I'll show you the password, so.
This one has a weak signal.
Ah, yeah, but he
As
just.
you
I can do with anything.
Yeah, he's not playing Steam.
I
He
just
just
want
needs to open it. Yeah.
Yeah.
It's not
I don't know why I didn't see it.
There you go. Can you see that? Okay. I like these classes where I can just sit here silently looking at you. It's good when you're tired and stressed. It's very relaxing.
Okay. What was right?
So, before we start there, Yusuf, is your question an Excel question or a maths question? What should I have open?
First one is an Excel question, but
Okay.
it's nothing like major.
Okay, go
I
ahead.
just want to know if there's a way I could calculate the.
Yeah, but you're not getting attendance, okay? Right. Yep.
Can I? Is there a way I can get the area of the triangle from Excel?
No. I am expecting students to read and estimate and calculate it.
Okay.
So there is no Excel formula, at
Mm.
least not that I know of.
And that's the way it, like the course work wants it to be done.
Yes, that's the way I want it to.
Okay.
So that's your Excel question. Did Farang have this question too?
Yeah.
Until now.
Kind of.
Do.
I thought
Farang,
there was a way to.
did
do
you
it.
hear my answer to Yusuf's first question? His question
I
was,
was just.
can you use Excel to calculate the area of the triangle?
Yeah.
No.
No, you cannot.
No?
You must do it by looking at it.
So what we do is wrong. The
No.
Simpson rule.
No.
That's not the area of this triangle. This triangle.
But that is
We didn't use that. No. This was for task. This is task 1. The other one is task 2. The one for Simpson and trapezoid rule.
Oh.
So
So
he
I'm
was
gonna ask
asking.
now. I'm gonna ask now.
Oh, you're
You asked the question in task 1 or task 2?
what?
Task 1.
Okay, now task
No,
2.
task 2.
Okay.
Yeah. We got 2 values for the area. One using the trapezoid rule and the other is using Simpson's rule, and they're different. I
Yes.
don't know why.
No, there should be.
Very different.
How different are they?
0.02 and 2.39.
Oh my heavens!
Yes.
Not only are they different, none of those are right.
Yeah.
Both of them
Oh.
are good. Yeah, because the answer should be nearly 1.
Yeah.
So you've done something horrendously wrong. Can I?
I already have.
Yeah. Do you wanna
Can
do-
we have a look? You had trouble using
And I forgot.
Farang.
Yeah.
What was your value of mu?
Mu.
Yeah,
I have everything.
6.
6. And what was yours? Roughly.
Can't remember. I think 4 or something.
Okay. So I'll use mu.
If you use mine.
No. I'll use mu. Come on.
Yeah. 6.
Mu.
It was 6, not 4.
Doesn't matter, because I'm using 5. Okay. Mu is 5. And sigma? What did you have for sigma?
Minus 4.
4. And what did you have?
I can't remember.
I'll also use 5. And what was your A?
I remember my A's.
What were
My
they?
A and B.
I minus 6.
Yep. And B?
18.
Okay. So first thing. How many pieces do we have when we use the trapezoid rule first? 10. Isn't that what I said first to use?
Yes.
It was
10
10.
or 11.
10. So we'll use 10 then. Okay. So we have to start at minus 6. That's the first point. But then we have to increase by h. And I'll write h here. So let me just put h here. And h is equal to, as you know, b minus a. Come on, you can do it. Over n. And I'll put the n in here. So that's the h. And then what I'll do, I'll just add h again. And I have to keep going until I get back to b, which is 18. The heck happened here? That shouldn't be the same. Yeah, but I can't.
The cell referencing. Absolute cell.
Oh, thank you. I'm glad somebody's awake, because I'm not. Yes, I should have this
No.
with the dollar sign.
Mine also can work. It's
There we go. What?
yeah.
What?
It's can't go to the data or coursework too.
Why not? Is my server down? Hang on.
It's not down, but it's just something.
Hang on, maybe my server's down. Let me check. Maybe it overheated. I'll have to call my wife to turn it off and turn it back on. Oh no! Server's unreachable. Ah. Oh no.
I just take a picture.
Uh,
And just now, like 3 seconds.
but it was working. It was working this
I
morning.
just have it and then
You broke my server.
No.
What were you doing to it?
I just take a picture of what I have.
You took a picture of my server.
No, I mean I take from my laptop.
My server can't have its picture taken. It's too shy.
No, it's my phone.
Right. My technician at home will fix the server later.
Yeah, breakfast.
Yes. Yeah.
I just
Yeah. Well, there's a switch on the wall where you can turn it off and turn it back on. I think this will fix it.
Is this going to be a process?
It will be. Yeah. Yeah. Okay. Now. Now that I have the
You got the height by minus
B minus A over N.
B minus A.
Yeah. Fuan or Yusuf, did you get the axis like this?
yeah.
No.
No.
We went up in ones.
Oh my goodness, there's the problem.
Yeah.
Oh, what's wrong?
What's wrong? You go up in H's.
We have them like minus 9, minus 8, minus 7, minus 6.
Yeah, that's what we do.
I went up in H's. H is B minus A over N.
You were there with us yesterday. Why didn't
B
you say that?
minus A over N.
Yeah.
Is that going to fix it? Is that going to be the problem? Just
I don't see.
B minus I. B minus I over. And where's N?
N, I say in the coursework, is 10. Let me just send
You
it.
said also R11.
Yeah, so you choose. It is a nice. Everybody likes 10. I'm just having the server reset. Do you want me to continue, or is that... That's a no then.
By the way, this is exactly Form's data. Exactly. Everything is the same.
Rah! What's the chances of that happening now?
Oh,
She is a lucky girl.
wait.
I'm doing it here.
How to do the X again?
Minus, you start by minus 6 and then add the H. Yeah.
Wow. Who's this going to be? Who's that? No, you're way too late. But I'll let you sit down, but no attendance, of course. Yeah? So sit down quietly. And we're going through the coursework here, some questions, Q&A. Don't worry, it's recording. Who was asking something? Or you were figuring it out?
No, I won't. Wait. How?
Could you flip the switch on and off?
How to X?
Is there what? Brigade? No. I saw you guys. Like I saw you standing at the station or something. Yeah. I thought I missed the bus, that's why I came second.
The bus didn't show up.
Which one did you catch?
48. We got 48 and then the cops stopped the walking sound on the
We stopped before
I don't know, they were checking
all the times.
all the times.
Well, that wasn't the roundabout, the spot roundabout.
Yeah.
No, that wasn't
Yeah.
the Oh. How many nines did you use?
How many we need?
Just 18.
One and
Oh,
then
okay.
11.
What?
After the first one, 33 and then
And 48 came, and then we stayed at the bottom corner and until 9.
oh, the plus 9 at 8:48.
Yeah.
Oh, okay.
And then we stayed at the roundabout.
And then we get the Y value.
Now, yeah. Do you need me to just do that
Did they
too?
check the plus?
No, that's
Guys!
when we get the Y values, what we do then?
Okay. I'll get that, guys.
Yes,
Guys!
the door.
Oh my goodness, calm down for one. He can't help it if he's a stupid boy, okay? Please. It's not his fault, okay? Be friendly to him. Guys, can I do the next part, which is calculating the y?
Yeah.
So, what is the formula? I don't have it here. It's like 1 over square root 2 pi sigma or something, is it?
2 pi
No,
sigma.
sigma square root 2 pi.
Okay, 1...
No, 1 over sigma times
Well, hang on. Okay, 1 over...
sigma times
Okay, sigma times square root
2 pi.
2 times pi. Okay, alright, chillax, chill. Right, so close the square root. Yes. Close the division, close that, and make these dollars. Alright, so that's the front. And now there's times an exponential part, isn't there? E power, and it's something like minus a half.
X minus mu.
That's going to be squared, isn't it?
Yes.
And inside is a fraction, isn't it? And on the top of the fraction is
X minus mu.
x minus mu, which in this case will be d2 minus mu, which in this case is b1. Okay?
Sigma.
Uh-huh.
Sigma is
Which is b2. Right, so that's what I got for y.
yes.
Oh, good. Good. And now we can use the trapezoid rule.
I think something's...
Now, just so you can be clear, index. So this is the first one. And this is the second term. And we finish at the 11th term. I thought I was supposed to finish at the n is 10. Oh, sorry, no. We start counting at 0. My bad. And we finish at the 10th term. Okay. Now, what's the trapezoid formula for the area? It's... What is it? Is it h over 2, is it?
Yes. Times...
Okay. h over 2. H over 2, yep. Times...
the Y values.
Yeah, it's the first plus the last plus twice the middle.
Yes.
Okay, so first plus last plus twice the sum the middles. Well, hey, that is not right.
I think your Y values are wrong.
No,
Oh, you went for the X's. You...
I highlighted the
Yeah.
wrong column. These should be E's. I know I'm right if this answer is near 1. So what went wrong for you, Yusuf?
I don't know.
Oh, okay.
That's all I figured out. Figured out later.
Good news, the server has been reactivated. Yes, you saw that. Just. Yes. Just thanking the technical support team.
Can you do the same thing for the Simpsons rule? Because I think the problem is...
Okay, so now repeat for Simpsons. Now, when you're using Simpsons rule, everything's actually the same. Well, of course not everything's the same, but at the start everything's the same. We calculate the h the same way. We calculate the y the same way. For Simpson, there is one condition though. The n needs to be an even number. So do we use 10 or 11 here?
10.
We use 10. So actually we can just reuse the values here. So this is the area using trapezoid. So I'll write area T. And this is the area using Simpson's rule. So what's Simpson's rule, please? I don't know it off the top of my head because I'm tired and sleepy. Simpson's rule, let's have a look. It is, yes, h over 3. First plus last plus twice the evens plus 4 times the odds. Okay, now that one is a little bit harder because you have evens and odds. So what I'll do to help me get Simpson's rule is I'll just separate out the evens and the odds. First, last, even, odd. Okay, so the first is this one. The last is this one. The evens are this one, plus this one, plus this one, plus this one, plus this one. Oh, did I pick D2? I shouldn't have, thanks. And this one. But I should start with D4. Yeah. And I don't need D12, goodness. So just these ones. And now the odds start with 1, 3, 5, 7, 9. Yeah? And Simpson's rule is what did you say? It's h over 3 times first plus last plus 2 times the evens plus 4 times the odd. And we want something to be nearly 1 as well. Did I pick... Did I do the same thing again?
I think so, because you got the...
I used X again here.
No.
Again, the same blooming mistake. That should have been with E's, not D's. There now. So we have the area using trapezoid and areas using Simpsons. In the coursework, what did I say the true area was?
0.99.
No, what I gave a number.
0.99 something.
So in this,
Simpsons closer.
Simpsons is closer.
0.9972.
Now Simpsons is closer for my data. Maybe it's not the same for you because yeah. Yours, the trapezoid is better, and I suppose this really makes the point that the shape actually can be important factor for which method.
It won't always be Simpson. That's better.
No. The point I wanted you to see, the Simpsons is usually better, but it's not always the best, and it's not that much different to trapezoid anyways. You know. But that's why we're doing a coursework, to explore, these methods. So then, Yusuf and Fuan, that's task 2. But then, did I ask you to do it again, but with n is 20 or something? Or I just wanted you to do each one once.
Mm.
That was it, yeah? So now,
Just ask for a percentage.
percentage error, yeah. Yeah. Yeah? Yeah? Will we have a look at task 3?
Maybe. No, I think it's fine. For me.
Yeah, no, I kind of came to terms with that, yeah.
No, like you said that 27 on.
Oh, okay. So, are we cool with task 1 and task 2? We're cool with that? This is the nod of coolness. That is the nod of coolness. Okay. So we can have a look at task 3 now. Yeah? Now, have you read task 3? I think it's quite interesting. Of course, I would say that since I made it. But what do you think of task 3? Your thoughts?
You mean how easy it is, or?
Well, do you understand what I'm looking for?
I think I do.
Let's have a look. In task 3, I give you this interesting formula. Loading. I told you that if you want to integrate a function from a to b dx, yeah, that's equal to b minus a times the average value of y, the average value of the function. Now you're like, oh, that's a very simple formula. Why can't I just use that all the time? Well, here's the problem. Although we know b and a, how can we get the average value of y? Well, how do you normally calculate an average? Yeah. So this means you have to add all the values of y, but there's infinite values because you can have as many as you like, because you could have 1, 1.1, 1.01, you could have so many values of y. So the idea behind this method is what you do is you make random x's to make random y's. Then you add them all up and divide by n, and then we have an average y. So let's test that out. Can I just remove this here? Yeah. And let me just remove this here. Okay. And this here. Right. Well, I want to keep my A and my B. Okay. Now, here we need to make some random numbers, and they need to be between -6 and 18. So in Excel you have this function called random, or a rand, is it? Yeah. But it makes a number just between 0 and 1, which is not what we want. How big is -6 to 18? It's 24 units long. So if you multiply random by 24, you'll get a number between 0 and 24. And we're nearly there. I want it to be between -6 and 18. So what do I do now?
Minus.
Yes? Come on.
Between 6 and 18.
Yeah. Oh.
Oh, like it has to be 18 exactly.
If you minus 6.
Yeah, but then that, you said between 6 and 18.
No, it's currently between 0 and 24. And now I want it to be between minus 6 and 18. So if I minus 6 off of the random number, I move it to the left. So it'll start at minus 6 instead of 0. I translate it. So this formula now will make the random number between 0 and minus 6 and 18. Oh, I don't know why it's small. And I'll copy this down here. So now we have all these random numbers. Why is my y? Oh, because I lost my mu and my sigma. It was 5 and it was 5, wasn't it? Okay. So now I have my y values. And according to this formula, the answer will just be b minus a times the average of y. Okay, let's try that out. b minus a times the average of y, which is average of these. Not bad. But what's really nice about this method is how easy it is to extend it. So if I copy this down, I can go down to wherever I like. Shall we go to 1,000? Why not? So if I go all the way back up here and I just change this to E 1001, I get 0.96. But what's one disadvantage with this method? What's one disadvantage with this method, do you think? I mean, it's an easy method to use because the formula is very simple. You make lots of random numbers, you get an average value for y, you put it into this formula, and you have the integration calculated. But there is a disadvantage. What is the disadvantage?
Repeated results.
What do you mean by that, though?
Because it's random numbers.
Yeah, so go on.
Like the system might use the same random numbers.
Yes. Oh, keep going. You're not too far away. But one problem is you get a different answer each time because the numbers are random, which is not good in maths. So if I was just to regenerate the random numbers, now I have a different answer. And it doesn't feel like it's as good as the previous methods because although I've made 1,000 numbers, I'm not exactly as accurate as I was before. Let's go and make a few more random numbers. How many did I actually suggest in the coursework? Was it 1,000? The only good news is that for a computer, making random numbers is an easy thing to do. In fact, you can do it on your calculator. Let's go to 4,000 and see if we can improve the accuracy much. Alright, let's see what we get. Now let's see how stable it is.
No, it's moving away.
It's still jumping around, you know. So it's an interesting method, but it's it's not a super great method. But it's interesting because you're using randomness to calculate the answer. It's kind of like, let me put it like this. It's kind of like you're making a sample, like a survey. You're randomly picking x's and asking the x's what is their value of y, and then you're averaging the y. So it's kind of like you're surveying the function. You're saying, you, number minus 5.92, what's your value of y? You add them all up and average them, and then just multiply the average by b minus a, and you now have the integration. And you might be wondering, why does that work? Well, it's kind of like this. When you take many values of x and get many values of y and get the average of y, it's like you're changing the function into a rectangle. So the area is going to be like this area now. B minus A times the average value of Y. So the process is kind of like flattening the curve into a rectangle, but keeping the area the same. Now it's easier to calculate. It's an interesting method, and a method you will learn about more at universities. And there are ways to improve the method. I just wanted you to have a basic idea, just for your own sort of learning. That's all tasks now, tasks 1, 2 and 3, so you shouldn't have any trouble finishing it. Right? Does that answer everybody's question? Andrew, did you have any about the coursework? Huang, any more questions about the coursework? Have you started, Huang? Yes, you have a question? What? What's wrong? Your area is wrong.
Big difference from the 0.8 something.
You know what's funny? Yusuf and Fuang had the same problem, and we fixed it at the start of the class when you weren't here. Oh no, you're making me sad now. I feel sad that I'm not helping you. But maybe Fuang or Yusuf can check your data and fix the mistake, because they had the same problem too. And usually with students, it's the same problem each time. The students, I know you all think you're special and different, but students are actually quite similar. I'll upload this video today.